reabsorption and secretion through your tubules, all right? This right here would be the renal artery, all right? The renal artery breaks off into the segmental artery. So here's a segmental, here's a segmental, there's another segmental artery. From the segmental arteries, we're going to go to the interlobar arteries. There's one here between the pyramid, all right? Here's another one here between these two pyramids. Here's another one here between these two pyramids. Remember, a lobe of the kidney is going to be a pyramid plus the column of the pyramid, and then the corresponding cortex. All right. So if this is a lobe here, here's another lobe there. There's another lobe there. So again, the arteries that project between the lobes are your interlobar arteries. It makes sense. Once the interlobar artery gets to the top of that pyramid, it now becomes the arcuate artery. All right, arcuate means an arch. Here's the arcuate artery here. All right, here's the continuation of the arcuate artery. Here's another arcuate artery here. All right, that's the arcuate artery. Off of the arcuate artery, we have the cortical radiate. Listen to the words, it makes sense. It radiates into the cortex. Cortical radiate. Here's another cortical radiate. Here's another cortical radiate, so on and so forth. All right. From the cortical radiate, it's going to go into the afferent arteriole. And our afferent arteriole, we'll see really good on this model right here. It's this structure right there. That is the structure coming off of the cortical radiate, our afferent arteriole, and that's going to lead us into our glomerulus, or Bowman's capsule. All right, which is this structure right there. Okay. That's the flow of blood in. The flow of blood out is the opposite. We'll go to the cortical radiate vein, to the arcuate vein, to the interlobar vein, and then right from the interlobar into the renal vein itself, which is this one right here. So here's your renal vein there. Here's your interlobar vein. Here's your arcuate vein, and this would be the cortical radiate vein. All these blue little structures that run next to the cortical radiate artery. All right. All right. On a general anatomy or gross anatomy of the kidney, this outer portion right here that my finger is touching is going to be the cortex of the kidney, which is going to be the outer portion of material. Where the pyramids run, all this pink section here, this pink section is going to be the medulla. So if I tell you to identify this area, I want you to put medulla. If I ask you to identify this structure, that would be a pyramid. All right, so area, the pyramids are in the medulla. Structure, the structure is the pyramid itself. All right, if I ask you to identify this area, the cortex, but I could ask you all this other little stuff that's inside the cortex. We'll look through that on these models here. All right, here's our renal pyramid. At the bottom of our pyramid, here's another pyramid right here. In between the pyramid, it's better on this model here. It shows them a little bit better. All right, let me use this one here because it is the same thing. Again, just a little bit different colors. All right, here's a pyramid here. Here's another pyramid there. Here's another pyramid here, so on and so forth. These are all pyramids. Again, a lobe is the pyramid plus the columns. This is a great description of a column right here. A column is in between the pyramids. Here's a great column. Here's another great column. So if I was to take half of that column and go through the cortex, and then take this side here, take that column, go through the cortex, that would be my lobe, all right? So at the bottom, your pyramid makes up the majority of that lobe. At the bottom of your pyramid, you have this little white structure down here, right here, right here, right here, all that little white structure. That white structure is the renal papilla. So the renal papilla is at the distal or bottom portion of your renal pyramid, all right? This structure right here, this structure there, so on and so forth, you'll see them right here. You'll see it. Those are your minor calyx. If I'm going to ask you on the test where the minor calyx is located, I'm going to give you either this one here or this one right here. Do not get mixed up between the minor calyx and the renal papillae. If I put it here, I'm looking for papillae. I'm not looking for pyramid for the calyx. The calyx will be on the cup itself. Okay, there's a calyx and there's a calyx. When we get two or more minor calyxes that come together, we get a major calyx. So your minor calyces lead into a major calyx. If I'm going to ask you to identify a major calyx, I'm going to ask you right here on the test. Because we have this minor calyx here and this minor calyx there to form a major calyx. So that would be your major calyx here. Here would be another major calyx here, another major calyx here. Again, where two or more minors come together. Those major calyces come together to form the renal pelvis. The renal pelvis is right in this area here. All right? And then the renal pelvis leads to the ureter, which is here. The ureter is the tube that takes the urine from our kidney to our bladder. The urethra is the tube that takes the urine from the bladder to the environment. All right? So the ureter is the first big tube, and that's right there. If I'm going to ask you to identify the ureter, you're going to see it somewhere down here. All right? Renal pelvis here. Major calyx there. Minor calyx here. Renal papillae, any of these little white structures. Renal pyramid, this pink structure up here. A renal column, this structure here, or that structure right here. All right? Cortex, the outside, the pink structure, the medulla. This structure in here, all this stuff together here, is your renal sinus. All right? So all the major calyces, your renal pelvis, that all makes up the renal sinus. All right? So from the outside in, cortex, medulla, renal sinus. Again, structure-wise, renal pelvis, area, renal sinus. Okay? When you take the test, you got to be very cognizant of what I'm asking you. You're going to read the question carefully. If I say area, I'm looking for those three areas: cortex, medulla, renal sinus. If I'm looking for structure here, I'm looking for the pelvis, renal pelvis. All right? Does that make sense?
Yeah.
Okay, it's just areas as opposed to little structures that are located within those areas. All right? All right. This here is showing our pyramid, and it's showing our two different types of nephrons. Okay? This nephron here on this side is going to be considered more of a cortical nephron, whereas the nephron on this side would be a juxtamedullary nephron. Look at how far down into the medulla it goes. All right? And this is how this works. Okay? Here is our interlobar artery. Here's our arcuate artery. Here's our cortical radiate artery. The artery that breaks off the cortical radiate and goes into the glomerulus is our afferent arteriole. Here's our afferent arteriole right there. Here's another afferent arteriole. Here's another afferent arteriole. Here's another one. Here's another one. They're the one breaking off of the cortical radiate going into the glomerulus. Those are your afferent arterioles. They're going to be right here on this structure. All right? Here's your efferent arteriole. Your afferent arteriole is thicker than your efferent because there's more pressure on this because of the heart, the blood pressure pushing into the afferent arteriole. Once it goes through the filtration system inside the glomerulus, the pressure's lower on the other side, so that efferent arteriole is smaller than the afferent. That's how you tell the difference. Afferent's fatter, the efferent is smaller. All right? Those are all described again right here. Here is your afferent arteriole. This little one coming out of the glomerulus would be the efferent. Here would be another efferent. Here would be another efferent. Here's another efferent. Here's another efferent, so on and so forth. All right? The one going into the glomerulus, afferent. The one leaving the glomerulus, efferent. Okay? All right. So once that blood goes into that glomerulus, it's going to be filtered in here. Whatever it passes through the glomerular capsule is now going to go into the proximal convoluted tubule. The proximal convoluted tubule comes right off of the glomerulus. Here it is right here. Here it is on there. Here's our proximal convoluted tubule. Here's our proximal convoluted tubule here for this nephron. All right? We're going to go from the proximal convoluted tubule to the descending loop, and then we're going to do the loop itself, and then we'll go to the ascending loop. That's going to lead us into our distal convoluted tubule, right here. And then from our distal convoluted tubule, we're going to go into the collecting duct. That collecting duct is going to take us all the way down until we get to the papillary duct, which is down here. And now that papillary duct is going to have a calyx sitting at the bottom of it, and that's going to drain into my minor calyx. All right, my little minor cup. Okay? So those are all the little tubules and how it all runs through those tubules. Let's do it one more time, all right? Interlobar artery, arcuate artery, cortical radiate, afferent arteriole, afferent arteriole. Filtration, the blood that's leaving will leave through the efferent arteriole. There's one right here. Here's another one here. There's another one here, so on and so forth, leaving the glomerulus, all right? The filtrate will now go into the tubules, the proximal convoluted tubule, the descending loop of the nephron, the loop itself, the ascending limb of the loop, the distal convoluted tubule, collecting duct to the papillary duct, all right? Millions of nephrons drain into these collecting ducts, not just the few that you see on here. There's millions of those. And they all eventually drain into that collecting duct, which will then again drain into the papillary duct. All right? So that's that. Let's go to this one here. All right? This is what I want you to know about this. Afferent arteriole, efferent arteriole, glomerulus. If I ask you this crap in here, I have something going across, identify the structure, glomerulus. All right? Glomerular capsule, Bowman's capsule, nephron, whatever you want to call it, pick one name, stick with it, all right? If I have it on the outside here, identify the structure, the Bowman's capsule, the nephron, the glomerular capsule, so on and so forth, all right? I could even say identify this space here and just have an arrow pointing to nowhere, glomerular space, the glomerular space, all right? That's where the glomerulus sits in. And then here, the proximal convoluted tubule. I could also ask you to identify this type of tissue. What type of tissue do you think that is, right? Or cell? What does it look like? If you had to guess. What size is it? What shape is it? A cube, a simple cuboidal, all right? Identify this cell, simple cuboidal cell. That makes up the tubules. This is my proximal convoluted tubule. This is my glomerulus, again, or Bowman's capsule, or nephron. Here's my glomerular space. Here's my glomerulus itself, my afferent arteriole, my efferent arteriole, all right? And this structure up here is called the macula densa, but you don't need to know that, all right? Just know the structures that I gave you down here, all right? And that's the kidney. Any questions about that?